What I want to do in this video is just to compare three generative AI models. So we're going to use a applied biostatistics problem just to calculate risk difference, relative risk or risk ratio, and the odds ratio together with their confidence intervals. And we're just going to compare these three models. So I'm going to have a look at Google Gemini. I'm going to have a look at Anthropic's Claude. And finally, I will look at ChatGPT. Can they solve these problems? How well do they do? So the first one that I'm going to show is Google Gemini. You can see the model that I selected here, 2.0 Pro Experimental. So that's the best model that's available to me at the time. Here is my first prompt. So here's our problem. You can read what I've done here. I'll read as well because you'll see I use very special notation there. I'll say a little bit something about it. So I've written, help me with the following biostatistics example problem. Researchers randomly select 242. Now you do see me, as always, put any kind of number, any kind of equation inside of dollar symbols. You do not have to do that. But that denotes that this should be read as LaTeX or LaTeX notation. That's mathematical typesetting. And the reason why I use that is a little bit later on, as you can see here, I write 1 minus alpha. You can see / alpha, and that is the alpha symbol that we use for level of significance, and so it just allows me to do mathematical typesetting. Now, whether an LLM recognizes this or not, who knows? I do use it in ChatGPT all the time. I think ChatGPT is particularly good at recognizing the LaTeX notation and really never has a problem with that. So that's why I always do it. As I say, you don't have to do it, but if you do want to enter a fairly complicated equation, how are you going to do it? And the LaTeX notation seems to work very well. So they randomly select 242 subjects from a population of people in care facilities. A random proportion of the subjects are veterans, and a random number of the subjects suffer from sleep disorders. The researchers want to test the claim that the risk of sleep disorders is different in veterans compared to non-veterans. So you've got these two categorical variables, and you want to know, are they associated? So instead of a table, that would be a contingency table. A total of 77 veterans had a sleep disorder and 45 did not. And a total of 35 non-veterans had a sleep disorder and 85 did not. So you get your 4 joint frequencies there. Calculate the risk difference. That's the difference in risk for sleep disorder comparing veterans to non-veterans. So we see that we have selected the presence of a sleep disorder. That's our disease. If a contingency table, that will be our D. And comparing those that were exposed to those that are not exposed, and we have chosen veterans to be the exposed and non-veterans to be the non-exposed. So then also the relative risk of a sleep disorder comparing veterans to non-veterans, and the odds ratio of a sleep disorder comparing veterans to non-veterans. So remember, those first two are risks, which are synonyms for probability or proportion, and the final one is a ratio of odds. And do remember, there's a difference between probability and odds. Then it goes on, also calculate the confidence interval of the risk difference, relative risk, and the odds ratio, and interpret the results. Use a level of significance, alpha equals 5, and then the percent symbol is outside of those dollar symbols. And a confidence level of 1 minus alpha equals 1 minus 0.05, that's 0.95. And if I want to express that as a percentage, that would be 95%. Consider the risk difference under the null hypothesis to be 0, and then the risk ratio and the odds ratio under the null hypothesis to be 1. So let's see what Gemini came up with. Very nice. At first, it broke down the problem into a contingency table, and we see the 4 joint frequencies there, and then the marginal frequencies with a total of 242. Then it goes on to calculate the risk. And those are the proportions. It seems to do the number of veterans with sleep disorder divided by the total number of veterans. So that's going to be a conditional probability there, as we require, both for the veterans and the non-veterans. And then it calculates the risk difference. That's the difference between those two, comes up with 0.3395, and then correctly states the risk of having sleep disorder is 33.95 percentage points greater in the veterans. So it says percent and percentage points. You should actually just say percentage points. But I guess that works. And then the relative risk, it's dividing those two conditional probabilities. It gets 2.1639, and it says veterans are 2.1639 times more likely to present a sleep disorder than non-veterans. So absolutely spot on. When it comes to the odds ratio, it does the multiplying along the main diagonal of our contingency table divided by the product across the cross diagonal. And it doesn't really tell us, what the equation is, where it gets these numbers from. So if you look at the table, you can find where those numbers are, but there's certainly no equation here, which to me is a little bit lacking. And anyway, it works out our odds ratio there, and it gets to 4.1422. So it says the odds of a sleep disorder are 4.1422 times higher in the veterans in comparison to the non-veterans. So I think all these calculations are correct. And then it goes on to the confidence intervals. And as you can see here, it's doing the standard error of the risk difference, then the confidence interval of the risk difference. So it's sort of giving us an equation, but that's how you would write the equation in text. So it's certainly not performing mathematical typesetting here, which for me is a bit of a loss, because if I look at this plus or minus z alpha over 2, at least it has a little alpha there. Anyway, it gets to 0.2215, 0.4575. So those are our 95% confidence intervals. Correctly express it there as percentages. I would have liked for it to say percentage point instead of the percent symbol, just because that's what we try to standardize on. When it comes to the confidence interval, it's got the standard error of the natural log of the relative risk or risk ratio. Remember, the relative risk under the null hypothesis in the frequentist approach is not normally distributed. So we do a transformation, which is the natural log or log transformation. And so we are expressing the standard error of the log of the relative risk. Again, gives this sort of text version of what the equation should look like. I always find that a bit difficult to read. Anyway, goes through, does remember at the end that we have to take the anti-log, or in other words, the inverse of the natural log, and that is exponentiation. So we take Euler's number e to the power, the upper limit and the lower limit, and that gives us that lower limit and the lower bound and the upper bound of the 95% confidence interval, and it expresses it there very nicely. And it also says the interval does not include the null hypothesis value of 1. So at a 95% confidence level, the relative risk is statistically significant. By the way, it also said that for the risk difference, so that's fine. It goes through the same thing with the odds ratio, and then reminds us that it does have to take the standard error is that of the natural log of the odds ratio, because the odds ratio is also not normally distributed under the null hypothesis. And we do this log transformation, it becomes more normally distributed, and we can use the z distribution. So our confidence coefficient, as you can see there, for both of the ratios, the relative risk and the odds ratio, is z alpha over 2, which is going to be 1.96. So we see that in both cases. It does remember to exponentiate both so that we can get the lower bound and the upper bound. And so there's the conclusion. You can pause and read that. I think it's a fairly good job. There's nothing wrong, other than I would find it difficult to follow these if this was the first time I'm looking at it, if I'm studying this for the first time. So I don't think that's the best way to represent the work, but certainly it had no problem, it had no problems with this problem. So let's go to what I would then put in second place, and that would be Claude. So here's Claude. There is my prompt. You can see it's the exact same prompt. I've copied and pasted it very nicely. Claude starts with creating a table of observed data, or otherwise known as a contingency table. And I won't spend as much time with this one. We've already seen what's going on. Claude does start there with the risk of sleep disorder in each group. So that's going to be our conditional probabilities there, then calculates that difference, the risk difference, comes up with the correct solution, calculates the risk ratio or relative risk, and it's got the correct solution there. Same for the odds ratio. And then it goes on to calculate the 95% confidence intervals. By the way, I think it does a good job also of expressing itself as far as the interpreting those the difference in the ratios are concerned. So that looks fine. And then calculating the 95% confidence intervals, and this kind of makes more sense. It's telling you, it's a much better typesetting of this equation. That's what I mean by mathematical typesetting. You can write this in LaTeX or LaTeX. You can create this, which is very nice. And then the typesetting is as I say, and that for me works very well. It's doing the standard error of the risk difference. Plugging in or substituting the correct values as far as that equation is concerned. Also just telling you what n sub 1 and n sub 2 is. Right over there, number of veterans, number of non-veterans, so very nice. Then it comes up with a 95% confidence interval and states it there. It does the same thing for the relative risk, and it's also doing the standard error for the natural log of the relative risk, and the same for the odds ratio. And it does also remember to exponentiate these so we get all the correct values. And then there's the nice interpretation, and it says the risk of sleep disorder is 33.94% higher. I like it to say 33.94 percentage points higher. But, there's absolutely nothing wrong with that. And since the 95% confidence interval does not include 0, the null hypothesis value, the difference is statistically significant at the 5% level. It does the same for relative risk and odds ratio. So I think all in all, very nice. You can learn from this, imagining that you tried this yourself first and then looked at this result. And I think that's absolutely great. Now I'm going to be very biased, and I'm going to put ChatGPT with the O3 mini high model there. By the way, for Claude, I use the Sonnet 3.7 model. I'm using O3 mini high here. It's a bit overkill, I think, for all of these, but anyway, it created a contingency table as before. What I do like is this real step-by-step way that it's thought through the problem. So it's going to calculate the values there for us, the conditional probabilities, calculate the risk difference, go immediately into doing the confidence interval. So it's right there. It's put out the equation there for us. Very nicely done. I'm just going to say it's marginally better. So I've got to put it in first place. So there's our relative risk or risk ratio. Even does both, the terms there for us, the calculation of it. It's showing us how to do the standard error, also of the natural log of the relative risk. You can see there its expression, which is algebraically equivalent to the ones that I would usually use in lecture. So that works out well, calculates everything, and does that nice interpretation at the end. It's doing the same for the odds ratio. So you can pause and have a look at it. Everything seems to be the same. And then the interpretation is very nice as well. I really have no issues with this, with the interpretation. You can also have a look at that. And what it does, it just gives us the 2.16 and the 4.16 as far as the difference in the two ratios are concerned. And then I said, gave an extra prompt, which I didn't do with the other two models, but I said, thank you, please express the relative risk as a percentage increase in risk and the odds ratio as a percentage increase in the odds, both odds of sleep disorder comparing veterans to non-veterans. And then it remembered how, it shows very nicely how to do that. Both of these values are more than the value under the null hypothesis. That's 1. So we subtract 1 from it. And that is 2.16 minus 1 times 100%. That's 116. So relative risk of 2.16, that's the same as 116% increase in the risk of sleep disorder comparing veterans to non-veterans. And the same for the odds. It's higher than 1, so we subtract 1 from it. Multiply by 100%, that leaves 4.16 as 316%. So there's a 316% increase in the odds of sleep disorder comparing the veterans to the non-veterans. So I think absolutely beautiful. Once again, you do this pen and paper first, then come and have a look at how these models solve this problem. And as you can see, they all do a terrific job. And I've got to give the slight edge to ChatGPT over Claude at this time. And I'm going to put Gemini right at the bottom, purely because the way that it has expressed the typesetting. But otherwise, the solutions are spot on.